If you noticed, I put three things on the calendar, and they're all relating to activity-based programming. And I'll talk a little bit about why I call it activity-based programming. It may have a name out there. It's just kind of what we define it as far as in the classroom. And we'll use a program called Etch as our example today. Just brief background. I am from Lumpkin County Middle School. I'm the engineering and technology teacher here. Have about 13 years of teaching experience, primarily in the science classroom. Everything from 6th grade science to 8th grade science and 9th grade science, 9th grade honor science. And then recently moved into teaching engineering and technology as a connections class. It was something I wanted to do and had wanted to do for a while. And when a connection spot opened up, I chose to move over into that connection spot and teach engineering and technology. To kind of give you just a quick background of why I teach computer programming, it's not directly in my standards. You can kind of find it if you read between the lines, but I'm not a computer science teacher, and the engineering and technology standards, again, don't directly say, teach computer programming or teach these elements of computer programming. How I got there was when I moved down into the engineering and technology class, I didn't have a budget. I had no budget currently, and I had no foreseeable budget. I had a limited space in which to operate. I know a lot of larger school programs have multiple rooms for their engineering programs. They have work rooms and computer rooms, and they have teaching rooms. I had a refurbished teacher workroom in which to put all of my students and all of my materials and all of the things that I could fit in there that I needed. There was no existing engineering and technology program at our school, so I didn't have any resources that I could use. I had no other teachers that had experience teaching it. And we had no, old kits or project materials that I could pull from a back room and use. And I managed to get 12 computers donated, and they were, like I say here, they were practically on life support. So they were best used for accessing the internet and doing web-based activities, but they could also be used for computer programming. And so I met with an individual over at University of North Georgia and talked about the practicality of me teaching computer programming as a very cost-effective way to reach a lot of students and teach engineering and have this program, get it started, kind of get some traction going, and maybe over the course of several years try to build a budget. That way I could bring into the classroom some of the resources and materials that I needed in order to teach the engineering and technology standards that I had. I didn't want the course to be students come in and listen to direct instruction. I did not want that kind of engineering environment or technology environment. I like to see myself as a facilitator. Students come in, I provide a general direction in which we're going, and then I assist each one as they move towards that goal. And that's best done, if you can put resources and materials in their hands that they can engage with and learn from. So what I've done since in the last 3 years is just write a lot of grants and trying to build that budget. And every year getting awarded a certain amount of money that I could then use to buy resources and materials. So over the last 3 years, I've managed to bring into the classroom some of the things that I need, but I'm still very limited in what I have. And computer programming was a good option for reaching those students and also teaching them a very relevant skill that they can use going forward. That being said, I had no experience teaching computer programming. It was something that I was interested in, something I had done on my own, something that I was learning at UNG, but I had never sat down and written a lesson on how to teach computer programming. And I didn't really realize, um, you know, what teaching styles there were for computer programming. I remember most of my classrooms and most of my engineering classes as we usually sat and listened, and it wasn't very exciting, but maybe we found that to be effective, over the last 20 years. So what I did in order to start teaching it was I had 12 computers. I would put 2 or 3 kids on one computer, depending on the size of the class, and I had some coding books. And I'm admitting that this is a very bad way to teach computer programming. I very much learned from experience. And I would give them the book, and I would try as best I could to describe what they were going to be learning. And then they would write the programs. One kid would hold the book, because I had very limited space, very limited resources, but one kid would hold the book, one kid would type it in, one kid would usually just not even pay attention. And then they would run the program and see what it does. And surprisingly, even in that limited environment, they enjoyed what they were doing. They liked the programs, they liked programming, and they felt very successful when they would get a program to run. We were learning a lot about, problem solving and troubleshooting errors. It was working. The kids were, to the most part, enjoying what they were doing, but I wasn't positive as a teacher that they were really engaging and learning how to interact with the computer or interact with the program, and really to create something from programming. So the next big step was I was checking out all of the computer labs in the school, and I would just rotate each class to a computer lab. That allowed every kid to have their own computer and every kid to have their own book. And it kind of became a one-to-one model where each kid worked through the programs on their own. And a lot less, disruptions, a lot more interest. They still enjoyed doing what they were doing, but it really wasn't any different than the prior model. It's just that every kid had a computer and every kid had a book. And I still can remember great moments when kids would write a program and they would hit run, and they would just be amazed by what it does, and really by what they had learned and what they were able to do and get a computer to do. So there still was some great moments there. But through discussions with them and trying to get them to write programs on their own, there really was a disconnect between students wanting to or being able to create their own programs and see a better response between what they were typing, what was actually happening or going to happen once they ran the program. And so I started over the summer and in this year really looking at, how can I teach computer programming in a way that's more engaging? And how can I, when students come into the classroom, that I just don't put a book in front of them and they write a program and see what happens? How can I get away from teaching vocabulary and then having them use it compared to having them do something and learn the vocabulary that they need? And one of the things I decided to do was to limit the number of programs that we write, to only pass out the books to if they needed them. I still model a lot of my programs after the ones I find in the book, but I don't pass the books out in the sense that they're just going to sit there and look at the pages and write what they see. So what I decided to do was create activities around every single program. That way, when they walked into the room, we weren't just getting out our computers and opening our book. We were participating in something and doing something that we were then going to break down the parts and pieces of, write the language that we needed for each of those pieces, and then see the outputted program as really a reflection of the thing that we had done in class. And it was much easier to engage them in the programming and much easier for them to think about the language, say, for example, functions or loops, to think about the things that they needed in order to have a working program that did what the activity had intended to do. So we'll come back to that in a second. We have some resources I think will be good. We have the Python programming website provides the environment for programming. It's free. It's easy to download. Actually, if you click the download link, it should detect what your system is and provide you the link to the appropriate download. I recommend 3.6.4. Should be the newest version. I use the Python programming language because it's very easy to read and it's also very easy to write. Thinking of programming as a language, I wanted to find something that I never was telling my kids, well, do this because I told you so, or that's just the way it is. I wanted to find something that was more readable for them. That way, when they looked at the program or looked at the code, they could more easily identify the parts and pieces. So I definitely would recommend if you're wanting to learn how to program or use programming in your classroom, I would start with Python. It's a good place to start. Teach Your Kids to Code is the book that I base my programs off of, and all of those codes are downloadable for free. I provide the link there. I think it's a great book for this age group. Very appropriate for middle school, but you can get the codes for free instead of having to buy the book if that's what you want to do. The Python Standard Library, I put it there as a resource, a lot like a dictionary. What I have found when I moved away from just giving them the book to write programs and we moved into actively writing programs and engaging in the programming process through activities is they began to ask a lot more questions. Can I do this? Can we do this? Can the program do this? How do I do that? And that, I knew the answer for a lot of those questions and some of them I didn't. And I would just be honest, hey, I know there's a function for that. I've never written that function or used it. I will go look it up in the library and I'll share it with you tomorrow. And I even had students that were more resourceful would actually go out to the library themselves, find some of the functions and bring them in and try to use them. And it just became a cool way to see how the activity was driving the language that they needed. And they were looking for more languages, meaning programming language and functions that I even intended for them to learn because they were engaging in the activity and they were more, the creative process was flowing for them and they knew they needed more colors on their palette or they needed more tools in their toolbox in order to write the programs. Two articles I definitely recommend reading. One's called Dear Everyone Teaching Programming. You're doing it wrong. It's kind of a bold statement, but it definitely is a good place to start reading. And then an essay that I would encourage everyone who's teaching programming or learning programming or would like to teach programming in the future is Learnable Programming. It definitely, and I'm still going through and assimilating and processing a lot of what that essay has to offer, but it's changing the way I approach teaching programming and really the goal and the outcome of programming. I mean, we want people going forward to use programs to create things in their lives and to accomplish tasks. We don't want the programming language to be so difficult to read or the programming environment in which you're programming to be so difficult to use that it inhibits the creative process. Programming isn't just for programming. Art isn't just for artists and cooking isn't just for chefs. We all in some way engage in those creative processes and over time get better at the ones that obviously that we practice and put more time in. But, programming shouldn't be one of those things that you avoid because it's just too difficult or you don't understand, you don't know the language. And I think what learnable programming talks about is creating an environment in a programming environment where it's easier for people to create and to write programs and how we go through that process. And then there's also a usable website called Chalk Traceable Programming where it actually goes through and allows you to manipulate a lot of the programs that the essay learnable programming is talking about. So they kind of go together. And I definitely encourage learnable programming as a must read. Um, so a couple of things that, and I'll hit on the main one is that and I'm going to talk a little bit more about these over the next 3 webinars, but the big one is that um, we shouldn't learn things in isolation. We learn things within context. If I was teaching my daughter to make a sandwich, we would never sit down and have a discussion about sandwich making. I would never have her write out the instructions for making a sandwich. And in that sense, is you're teaching that process out of context. I'm gonna move into the kitchen and we're gonna start looking around and finding the ingredients and finding things that we need, and asking questions about the types of bread, or do we need jelly, or is this a banana sandwich, whatever, and we're gonna pull all those ingredients together. And the neat thing is while you're pulling those ingredients together, you're seeing what the finished product is going to look like while you're creating it. And that's one of the things that learnable programming talks about, is that programming needs to be something that while you're doing it, you're seeing what the output is. And while you make adjustments to your program, you're seeing what those adjustments look like as the end product. If you walk into an art room and you grab some painting materials, you need to be able to, while you're using them, you're going to immediately see what that creative process looks like. You don't have to mix colors and then imagine what that color is going to look like. You see the output of that immediately. So one of the things that learnable programming talks about is teaching within context, and the programming environment should help with that context. While you're doing it, you see what the output is. It's very tangible, very visible, and very usable. And that's something that I tried to create through the activity-based programming, that while they were participating in the activity, they were seeing what the outputs needed to look like. It's not a perfect translation of what is being talked about in the essay, but it's closer. It's a closer approximation from what I was doing, was just having kids write programs and imagining what the output was going to look like. We really want to get to a place where while we're writing programming, we're seeing what the output looks like. So some other points in there. So the one program that I do is called, it's an Etch a Sketch program. And essentially what it is, it's a single line drawing where you never pick the pen up off the paper. And a great way to start this program or this activity is if you have them. If you have a classroom instead of Etch a Sketches, you just pass them out as the kids come in, and you allow them to manipulate the dials and see what happens. And that, in a perfect world, is what programming should be. As you're manipulating the programming language, you're seeing what the output looks like. And in the case of an Etch a Sketch, as you turn one dial left or right and turn the other one up or down, it draws these pictures out. And I am not proficient in Etch a Sketching, and I did a lot more shaking than I ever did drawing. But if you don't have a classroom set of Etch a Sketches, you can just talk about single line drawing and bring up some examples on the computer, or have them bring up some examples on their computer. And there's some really amazing examples out there of what single line drawings look like. You could talk about the artists, or bring in the art teacher, and sometimes we do that. We just swap classrooms. The art teacher comes in here for 10 minutes, talks about the idea behind single line art, and some of the principles and properties of it, and then we just switch back classes. So if you don't have an Etch a Sketch, then you can just simply have the kids take a sheet of paper. Now it's kind of using this as an example. You can take, I chose the Mona Lisa, and then I did a single line drawing of the Mona Lisa in the middle. And the neat thing is while you're drawing, you see what the output looks like. And if you don't like it, you can undo or just, erase if you're using an eraser or a pencil, or you can just throw it away and start again and immediately start seeing the outputs of what your next program looks like. So the picture on the left is actually Mona Lisa. I don't know if you could tell between the three which one was which. The one in the middle is my pen drawing, and then the one on the right is my extra sketch using the program that I had the students write. And the neat thing is, from the middle picture to the right picture, there's a lot of exploration. There's a lot of doing things in the program and trying things and asking questions. And can I do this? And can I change background color? Can I change pen width? Can I undo what I just did? I made a mistake. I don't want to start over. And they start, the learning process and the creative process starts to drive itself. And you go from teaching, here's a book, write this program, see what it does, to not even being able to answer the questions fast enough. So what I'll do is I'll hop out and I'll show you what this process looks like. Any questions at this point? I see, Deepa, I think you're asking, it's 3.64, I think is the most stable version right now. So I'm going to hop out and just show you.
So Brian, really quickly.
Yes, ma'am.
Do we have to have the latest version for Python, you think?
Well, not necessarily, not for everything. I would recommend using the newer version, but you don't know. There are some things like Pygame, for example, if you want to integrate Pygame into Python, that works better with certain versions. But I wouldn't, if you're just doing introductory programming as a couple of lessons, I would just use one of the two versions that they provide.
Thanks.
And I actually think, and I haven't checked this, but I've heard that the new Microsoft version actually comes with, I think, a version of Python with it. I need to go back and just check that and see. So outside of doing a tutorial on how to install Python, it's very straightforward. The website, you just download it and then you run it and install it. But it's very straightforward. But y'all can see my screen still, correct, Deepa?
Yes.
Okay. So initially, when you open up Python, this is the screen that you see, and this is where I start my students. And we do have a great discussion about the creative process and that a lot of the apps and the programs that they write and use start on a blank sheet of programming paper. And what I'd like to see in a perfect world is that blank sheet of paper, the environment in which you are programming doesn't inhibit the creative process, right? That it actually facilitates and helps you create. So one of the things we need to do is there's a program called Turtle. It's an old program and it's a graphics program, and I do talk to them a little bit about you don't have all the information available to you that you need. It's like if you went to a library, you don't check out all of the books just to get one book. And programming a lot of times is the same way. Sometimes you have to bring in a book of resources that you plan to use in your program. And we've had conversations prior to that about why that's important. But one of the first things we do is we import that Turtle graphics program into our program, and we're programming in the shell right now. It's just a fun, easy way for them to start the process, and then really the language kind of speaks for itself. The Turtle is actually going to be what they draw with, so we call it Turtle. And then we're going to just set up its pen color, which makes sense. It's a pen color because we want to draw with the pen. And I generally use a color that that they have with them right then. So as soon as you type Turtle and you give it a pen color, if you notice from my screen, the drawing paper, just like we had on our desk, pops up, and I'm trying to resize it here, but not doing a very good job. Um, and now they can begin the creative process. And I'll give them some information to get them started, but then allow those questions and things to flow. Um, to make it more readable, I generally have them turn the turtle into a turtle, and it's so you take the turtle and you change its shape to a turtle. If you notice on my right hand screen, it changes to a turtle. And now when we're writing directions or giving directions, it's easier for them to understand the movement side of it. So, I want the turtle. Ask them, if you're going to be drawing the Mona Lisa, what do we need to have the turtle do now? If you're drawing the single line drawing from the guitar that you have on your paper, what do you need to have the turtle do now? And they understand the movement side of it, the creative side of it. Well, I want to move it forward. And so you would just tell the turtle to go forward, and you would tell it how far that you want it to go forward, and then it moves. Now understand that where we end up is not where we start. I'm trying to get the programming process in my classroom to be a more active, living, engaging thing. So I don't tell them immediately that there's an easier way to do this single line drawing than to type in each command as you go. But I want the process to drive the language that they need, or the functions that they need. Because until they realize they need it, they're not going to learn it, or they're going to learn it when they realize they need it. And I really believe that language is something that, the words that I use, on the language that I use, I've learned much more than what I use on a regular basis. And what I want in this programming, on these activity-based programming, is I want the process to drive what they need, because once they need it, they're going to learn it. And I found that they remember programming language better from things that they knew that they needed, or sensed they needed. So I don't know if that's the best explanation of that, but they know that if they want to take the turtle and turn him, he needs to turn to the left in order to face a different direction. And we talk a little bit about degrees and turning the turtle left, right, or forward using degrees. And then we might move him again. And you'll have students do this for 10 or 15 minutes, just driving the turtle around the screen, trying as best they can to make an Etch-a-Sketch of the drawing that they have on their table. And they begin to realize that the language, the programming language, isn't necessarily keeping them from doing that, but it's a little bit cumbersome. It's not as, they begin to recognize that it's not as easy as it could be. But a couple other examples is they'll start asking you, can you change the background color? And the answer is yes. You can easily just type in turtle, change the background color, so BG color, and then it turns it to green. They'll ask you if you can change the pen color. And you just, tell them, hey, yeah, you change the pen color by telling the turtle to change the pen color. I'm just using basic colors here. We'll change it to red. They might ask you, can you make the line wider? And, it's the language that they use is pretty much what they asked me. Can you make it thicker, or can you change the width? And you can easily change the width and then move the turtle again, assuming my spelling is good. And I'm going to move him, let's see, 75, so you can see it. So it changes the width. They'll begin asking, oh, I made a mistake. Can I go back and change that? And they begin learning way more functions than I could have or wanted to teach them in isolation. So, you just undo what you did before. And if you look there, they not only have learned to import a library of code, They learn the function for changing the pen color, the shape, the movement, direction, the background color, the width, and undo. And they will remember those functions during the course of the year. So, as the class progresses, they begin to think that, how they're using the programming language is not as easy as when they were drawing the picture. And so that creative process is breaking down. And they realize that because it's so much easier to sit there and draw with your pencil and draw single line drawing than it is to do this. And at some point, someone might ask me if they can just click on the screen to move the turtle. And that's when I finally give them the on-screen click function. All right. So basically, you're taking the turtle, and when you click on the screen, on-screen click, we want to take the turtle and set its position. And when I hit enter, now when I move into my screen, I can move the turtle just by clicking on it, and it makes it much easier to begin drawing their single line drawing. And now the programming is more directly modeling the creative process that they were using when they were doing the Etch-a-Sketch. They can still come over here and change the color and change the background and change the width and come back over and keep working on their drawing. I'm not even very good at on-screen clicking, but it's being taught a little bit more in context. They see what's happening every time they do it. They immediately see when they change the pen color or change the width or move the turtle. They don't have to write it in a programming sheet, have it compiled, and then hit run and see what happens, and then go back and make changes. They're seeing the immediate changes step by step. It's not a perfect translation to what we're talking about in learnable programming, but I feel like it's moving better. It's moving in the right direction, and I feel like, and I'm seeing students. I'm trying to get back to the screen. Sorry. What I'm looking for is, can they take a programming challenge and break it into smaller pieces? Can they remember the language that they need for each of those pieces if they had to use them in a new program going forward? And are they more encouraged to create using programming because the language and the programming environment isn't keeping them from that creative process? And I'm finding we're moving in a lot more positive directions and on all of those points. They're more excited to come in and program. They're more engaged in the activities. They're remembering code. I can come into class now and have an activity, and they're already thinking about the language that they need in order to get the program to execute and do it. So that's the direction I'm moving. If you have any questions over the next two webinars, I was going to show you two more activities that I use. The kids really enjoy. The computational thinking side of it. We actually wrote a program where the activity took 2 class periods because I don't give them what they need until they need it. And we had a challenge that really took them 2 class periods to break the parts and pieces down before they could even start asking me for the right parts and for the right language. Hey, we've now figured out how we want this program needs to be created. Now we need to kind of know some of the language that we needed in order to do it. And it was a fun experience. So I guess I'll hop back over and see if y'all have any questions or.
I think this is really great. I think middle school kids will really, really like this turtle programming. I think maybe the next 2 webinars or even after that, maybe very detailed projects on how this turtle programming is used. And it's Python, is it not, Brian?
Yeah, it's just Python. Yes, ma'am.
I think I think we'll talk a little bit offline as well, but I think focusing on that and giving significant assignments would be fantastic. The Brian has a question.